All right, so let's talk about events. Mutually exclusive and equally likely. Events mutually exclusive or equally likely. All right, so first of all, it says an event is a subset of a sample space. All right, it's sort of like sound like the definition for sample point. So an event is a subset of a sample space, or I'm getting that the fact that let's say it's a subset, I guess an event could have a collection of what? Sample points. All right. For example, as head-to-head is an event when tossing two coins. And it is also a sample point. Two events, A and B, are mutually exclusive if they cannot occur at the same time. Two events, A and B, are mutually exclusive if they cannot occur at the same time. Later on, we'll find out that the probability of mutually exclusive events, they cannot occur at the same time, you would add the probability. So what you would talk about is that you would talk about the probability of what? A or B, or the probability of A union B, and it should be equal to the probability of A plus the probability of B. Now, this is something that we actually did from what CSEC. Most people probably won't remember, but mutually exclusive events are two events, A and B, are mutually exclusive if they cannot occur at the together, or they cannot occur at the same time. Now, the outcomes of an experiment are equally likely to occur when they have the same chance of occurring. For example, when tossing a fair coin, you're equally likely to get a head or a tail. When you roll a fair die, you're equally likely to roll a 1, 2, 3, 4, a 5, or a 6. Events are exhaustive if they combine to give the entire probability space. What is probability? Probability, the chance or probability of an event happening. So probability is the chance of something occurring. So the chance or probability of an event happening is the number of ways in which the event can happen divided by the total number of events. We can write this as the probability of event A occurring is equal to the number of times A occurs divided by the total number of outcomes. Example 4 says Kadeen tossed a die 96 times for applied mathematics unit 1 internal assessment, and she obtained 26s. What is the estimate of the probability of her getting a 6? A, based on her results, and B, based on her expectations. All right, so let's have a go at example 4. We'll do 4, 5, and 6. So example 4, I'll read it again. It says Kadeen tossed a die 96 times in her applied mathematics unit 1 internal assessment, and she obtained 26s. What is the estimate of her probability of the probability of her getting a 6A based on her results? Well, the probability of getting a 6 will be the number of times she got a 6, which is what? Over the total number of times she could have gotten a 6, which is what? 96. All right, can we simplify that to what? 5 over how much? Over 24. All right, based on her expectation. Well, if the die is fair, you're expecting that you would get what? You'll get a 6 what? every six throw, you'd expect to get a what? A 6. So the probability of getting a 6 based on the expectation is simply just what? 1/6. 1 in 6. That is, if somebody asks you to calculate the probability of getting a 6, you would say the number of 6 on the die is what? 1. The die has what? 6 faces. So your expected probability of getting a 6 is what? 1/6. All right, example 5 says, find the probability of getting exactly 3 heads. B, exactly 2 heads when 3 coins are what? Tossed. Are tossed once. So 3 coins are tossed once. What is the probability of getting 3 heads? First of all, 3 coins are tossed once. The probability of getting a head, of getting 3 heads, getting 3 heads in this case, they're independent events. So I'll explain independent events in a second. So the probability A, the probability of getting head, head, head. Y'all might not remember, but from question number what? Example 1, was it? Example 1 is that exact scenario where there are what? How many possible outcomes? Talk to me now. There are 8 possible outcomes. So the possibility of getting, and how many heads are there? 1. So the probability of getting head is what? 1 out of what? 8. Or you could do it like this. It's a half times a half times a half, which is what? 1/8. Why a half times a half times a half? Because the probability of getting head, the probability of getting 3 heads, those are independent events. Meaning that getting a head on the first coin has nothing to do with getting a head on the what? Second coin. Or it does not influence getting a head on the second coin, nor influence getting a head on the what? On the third coin. All right? So they're independent events. But for now, let us leave out the independent events. That will come back later on. There's only one outcome in which you could get what? Head. And there are 8 possible outcomes, so it's 1 out of 8 head. 1 out of 8. The probability of getting exactly 2 heads, well, let's rewrite the outcomes. I don't want to go back up. You have what? Head, tail, head, tail, tail, head, tail, tail, head, tail, head, tail, head, and what? Tail. All right, how many times do you see exactly 2 heads? 1, 2, only 3 times, don't it? 3 times out of how many? So the probability of 2 heads exactly would be 3 out of 8. Example 6. There are 12 green markers, 8 red markers in a bag. So there are a total of 20 markers in the bag. Allison picks 1 marker from the bag without looking at them. What is the probability of Allison getting a red marker? Well, that's simple. The probability of getting a red would be the number of reds in the bag, which is what? 8, over the total number of markers, which is what? 20. So this works out to be what? 2 out of 5? Want you 2 over 5? All right, just give me a second. All right, next we're going to start looking at probability rules.